Hello and welcome to this R tutorial. So now it's time for the fun part. I can't wait to show you the training set results and the test set results. So let's start to build the graphs. So the first thing we're going to do is to import the ggplot2 library, which is a very good way of plotting something in R. So I'm going to import it. But before importing this library, there might be some of you who are starting R for the first time. So if we go to our packages here, you can see that the ggplot2 library is here on my RStudio, but it might not be the case for you and that would mean that the ggplot2 library is not installed on your R. So just for those of you for which it's the case, I'm going to install ggplot2 library. So we have to use this command install packages here, and then in parentheses we add ggplot2, ggplot2. Then we select this, press Command or Control plus Enter to execute. And here right now you can see it's installing the library, and that's done. So that's the message you should be obtaining when you install a package. Now it should be appearing in your library, so mine is here. And we are ready to start plotting the graph. I'm just going to put that in comment. So Command Shift plus C, now it's in comment because once it's installed we don't need to install it again. Okay, so now let's start to plot our training set results graph. So first thing we need to do, as you can see, the ggplot2 library is not selected here, so we will need to select it. But we want to automate all this if we want to use simple linear regression on another data set. So we will just type here library, then in parentheses the name of the library, not in quote actually, ggplot2. And as you can see, if I select this line and execute, here you see that it's not selected, and if I execute, it's selected. Here we just have a suggestion to type suppress package startup messages to eliminate package startup messages. Well, that's not very important. You can execute that if you don't want the package startup messages, but that's okay. So I'm just going to enlarge this. Okay, and now like for this course, the approach we will be taking to build this graph with ggplot2 is going to be a step-by-step approach, because we are first going to plot all the observation points in the training set, then we're going to plot the regression line, and then we're going to add a title, and then a label to the x-axis and a label to the y-axis. So you know it's going to be step-by-step. First the observation points, then the regression line, then the title, then the labels. Okay, so let's start with the observation points. So generally, to introduce a plot in ggplot, we start by typing ggplot parentheses. All right, and then that's when we start to build step by step the little components of our graph. And since we're adding each component one by one, we are going to separate each of these components by a plus. So let's go for the first component, plus here. I will press Enter, and here we go for the first component. So the first component are the observation points. So very intuitively, we are going to write geom_point. All right. So we are going to use this function of ggplot to scatter plot all our observation points of the training set. So the first thing that we need to do is to precise which are going to be the x-axis and the y-axis, and that's in the aesthetic function, which we call AES. So that's the function that will take as input the x variables and the y variable. So the x variables is our years experience variable, that means the number of years of experience. That's what we want to have in the x-axis, and the y variable will be our salaries, but the real ones, not the predicted ones yet. So therefore we're going to add in parentheses x equals, and then we're going to put all our years of experience. But be careful, we want to take the years of experience of the observations in a training set. So here we'll just have to specify training set $, and then years experience. So that means that we are taking the years experience values of the observations in the training set. Okay? And now same for y. And here we do the same, only with the salaries, which is here. Okay. And that plots all your observation points, the real ones, in the plot. Okay, so we could stop here, but we would like to add a color because we will want to make the distinction between the observation point and the regression line to, make a nice plot. So comma here, and then I'm going to press enter to add a new argument of geom point, because this can be a little confusing here. We have a comma here and a comma here. This comma here is just to separate the x and the y in the aesthetic function, and this comma here is to separate the first argument and the second argument of the geom point function. So the second argument is color, and let's pick red. I usually like to have my observation points in red, but that's just my taste. If you have some other taste, you're welcome to choose your favorite color for the observation points. Okay, so that's it for the geom point. With this geom point part here, we are plotting all the observation points of our training set. And now let's add the following component, which is our regression line. So here we add a little plus and then enter. So to plot the observation points, we used geom point, and now very intuitively to plot the regression line, we're going to use geom line. All right, so pretty easy to remember. And then in this line, same as for the point, we're going to take the x coordinate and the y coordinate of our regression line. So let's see, first we need to take the function aesthetic, AES, parenthesis, and that's where we put the x and the y. So in your opinion, what is going to be the x? Well, the x is going to be the year's experience of the training set, because we want to have the predictions of the salaries for the observations in the training set. So in the x-axis, we need to have the number of years of experience of the training set observations. So here I'm just going to copy this there and paste it here. But now, what is going to be the y? It's not going to be training set salary, obviously, because we don't want to take the real salaries. Now we want to take the predicted salaries. So in order to take the predicted salaries, we will very simply use again this predict function. We cannot use again ypred here, because ypred is the predicted salaries of the test set observations. But here we want to get the training set predicted salaries. So we will copy this, predict, to take the predictions of the training set salaries, and therefore in new data here, we need to replace test set by training set. And now it's good. Now this geom line function here will plot all the predicted salaries of the training set observations. And so for each employee with the same number of years of experience, because here we have the same X, we're going to have both the real salaries, the salaries they actually have in the company, and the salaries predicted by our simple linear regression model for the same employees. Okay, so it's ready, the line is ready, but as for the observation points, we will just add a color, and then that means that we need to put a comma here and press enter. And that's where we put the second argument, which is going to be the color, and this time we will pick a blue color. So again, that's just my taste. You're welcome to use some other colors if you prefer. Okay, so now our plot is almost ready. We have all the observation points of the training set. We have the regression line. And so now we could plot the graph now, but if we want to have a nice graph that we want to present to people like managers or clients or even your friends, it's always better to add a little title and some labels on the axis. So let's do this, plus here, and GG, so this time it's not geom, it's GG because it's not a geometrical thing, GG title, parenthesis, quotes, because we have to put the title of our plot in quotes, and here we're going to give the following title, salary vs experience. And we are going to specify that it's the training set, because then we will do the same for the test set. And close the parenthesis, and that's it. So perfect, that's our title. And now let's just add a name of the x-axis. So to do this, we use the xlab, and in parenthesis, we will say that the name of our x-axis is going to be years of experience. Okay, and then plus, and then same for our y-axis, and obviously it's going to be ylab, and here we'll choose salary, very simply. Okay, and our graph is ready to be plotted. So I'm going to select all this and now press Command or Control plus Enter to execute. And here is our beautiful graph. So that's the training set results with the real training set observations with the real salaries in red and the regression line in blue. So let's zoom this graph and let's give an interpretation. Alright, so this is our training set results. So we can clearly make the distinction between the real observations, which are the red points. So these are the real salaries of the employees in the company. And this blue straight line here is our linear regression model. So that's the prediction. That means that, for example, if we take this employee here, well, we can see that his number of years of experience is a little more than 5 years of experience. His real salary is about $65,000. But our model predicted for this particular employee this result here. That means he predicted that this employee has a salary of a little less than $75,000. Okay, so that's the real important distinction to understand. This is the real value and this is the predicted value of the model. And to get the predicted salary, you need to project this point of the line here onto the salary axis, which gives us a predicted salary of a little less than $75,000. Alright, so that's the results of the training set. These are quite good results, but that's because we trained our linear regression models on the training set. And now let's see how our simple linear regression model can predict new observations, that is, new observations of the test set. So I'm going to close that. Okay, and now let's do the same for the test sets to see if our simple linear regression can make some good predictions on new observations. So the test set observations on which our model wasn't built. So as usual, we want to be efficient, and so we're going to copy all this, copy, and paste it here. Okay, so let's replace all the training set here by test set. Okay, here as well, training set, test set, that's the test set results. Okay, so now we must be careful with something. Let's see if we have to replace all the training sets. So in the first component of ggplot, that is when we plot all the observation points, the real observations, here we have training set years experience and training set salary. In your opinion, do we need to change training set here by test set? Yes, of course, because this time we want to have the observation points of the test set. So we want to take the years experience here of the test set observations and the salaries of the test set observations. And here we will replace training set by test set. Okay, but now in geomline, so that is the component that builds a regression line, do we need to replace training set by test set here? You know, training set here and training set here. Do we need to replace those two training sets by test set? Well, the answer is actually, of course, no, because our regressor is already trained on the training set, so whether we keep here the training set or replace by test set, we will obtain the same simple linear regression line. Indeed, if we replaced here training set by test set, we would just build some new points of the same regression line corresponding to the new predictions of the test set observation points, because when we trained our simple linear regressor on the training set, we obtained one unique model equation, which is the simple linear equation itself. And therefore, whether we build the regression line here by predicting the training set points or the test set points, well, since these predictions result from the same unique simple linear equation, we will get the same regression line. Okay, now, so that means that now we're ready. Okay, test set here, and training set here. We're all good. We are ready to plot the test set results to find out how our simple linear regression behaves on new observations. So let's do this. Press Command and Control plus Enter to execute. And here we go. So as you can see, as I was telling you, if we go back to the training set here, you can see that only the red points change, you see, and the blue regression line doesn't change. You see, it's the same. Here, only the red points change. So here, that's the training set observation points with the model built on the training set. And here, that's the test set observations with the same regression line built on the training set. Okay, so now let's zoom on the test set plot and give some interpretation. Okay, so the test set results are actually not bad. We can see that we have some very good predictions here. For example, for this employee, this employee, this employee, and this one as well. Because as you can see, the real value is close to the prediction, which is on the blue regression line. So since these are new observations on which our simple linear regression model didn't learn any correlation, that's actually quite a good job to find, predictions so close to the real value. And of course, there are some predictions that are further from the real value, but that's because there is not 100% linear dependency between the salary and the years of experience. But for sure, there is a certain linear dependency. Alright, so thank you for watching this tutorial about simple linear regression. In the next section, we will find out about a new type of linear regression, which is going to be the multiple linear regression, meaning that instead of having only one independent variable, we'll have several independent variables that will predict a single dependent variable. So there will be a new business problem, and I can't wait to solve it with you using multiple linear regression. I'll see you in the next section, and until then, enjoy machine learning!